All right, ladies. If I recall correctly, you're doing different indices of refraction, and you're finding the velocity or the speed of light at those different indices. Okay, and you probably have a table of different things like air, water, diamonds, whatever, right? That came from the equation, the indice of a vacuum, which is 0, times the speed of light in a vacuum, which I think is 3 times 10 to the 8th power. Indice of refraction of your new thing times velocity of your new thing. Okay, what you should do is you should make a graph of your data. You are changing the indice of refraction, and you are finding the velocity in your new object. You are solving for this, right? This equation turns into V1 is equal to NV right here, okay, times velocity in a vacuum, the indice of refraction in a vacuum, times velocity in a vacuum, all over the indice of refraction of your new thing, okay? You're going to get a graph here, right? This is the indice of refraction of 1. I'm going to write this equation separately. V1 will equal indice of refraction in a vacuum times velocity of light in a vacuum times 1 over N1. Looking at this, notice that your graph will not be linear, okay? May look something like that. When you graph it, think of a way to write an equation for that graph. Instead of graphing, you should have one graph where it's V1 versus N1, right? And then you should also include another graph where it's V1 versus 1 over N1, much like this right here, okay? That graph is what you need to do in order to get a linear line. The slope of that graph should be, here if we have y equals m times x, if this is your x, this is your y, then this would be your m. So your slope should be equal to the indice of refraction in a vacuum, which is 1, times the speed of light in a vacuum, which is 3 times 10 to the 8. I'd expect your slope of this graph to be 3 times 10 to the 8. Show both of the graphs. Show the calculations. Good luck.